So before we start the session, I will just like to introduce myself. So that's me. I'm Sri Rajashekar Ravi. So I'm currently a tutor and mentor at Algomist Labs. So what we do at Algomist Labs is we are a edutech company, and we do mentorships and workshops for students in colleges and also for professionals. So we mentor in the trending technologies like machine learning, blockchain, AWS. So that's what we do. And this is our team. So we are a group of people working in trending technologies in some of the best companies, and we like mentoring. We like to mentor, so that's why we are doing this. And yeah, that's all about Alchemist Labs. And I'm also an API software engineer with Barclays UK. So I work with APIs that handle payments, billions of payments from millions of people across UK and Europe on a day-to-day basis. And before starting to work as a API software engineer, I was working as a junior data scientist with this restaurant intelligence company called Yumpingo Limited. So there are a very interesting people. So what they do is they collect reviews from people who are dining in a restaurant, and then provide their customer experience in a real-time basis to the restaurant manager. So my job there was uh, to identify data manipulation in the reviews collected by the server who is handling the session, and that was basically my master's thesis, and it was about fraud detection. So I was doing my master's in Internet of Things and data analysis, basically data analysis for IoT data from Queen Mary University of London. And prior to that, I was a full stack developer or a software engineer with Verizon. I was working there for a little over 2 years. And before that, I was doing my bachelor's degree in electronics and instrumentation engineering from St. Joseph's College of Engineering. So I'm basically an alumni, and I'm very happy to be part of the cohort once again. So once again, thank you guys for inviting me to this session. So many people would have seen these steps a lot of times because you guys are already working on data science. So what is the point of going through these points all over again? It's because this session is mainly about bringing in new tools and resources that I have found uh, interesting and might be useful for you in your data science venture. So these are the steps for any data science lifecycle project, a data science project. So you can basically fit in any DS project into these steps. So what I'm going to do in this session is I'm going to give some tools and resources for each and every step in the lifecycle. So the first step is problem statement. So there aren't any tools or resources for the problem statement because it is an abstract thought. You take up a problem, you try to solve it. So, and this is the most important step in the life cycle process. um, this is the most important step, because if you're not clear about the problem, if you're not clear about what you're trying to solve, you obviously won't have a good model or good product at the end. And then the data source identification, selection and extraction process. uh, So we have tools and resources for that, which will be coming up in the upcoming slides. So we'll quickly move on to how much time we are spending on each of these steps. So this is a breakdown of the percentage of time that we'll be spending in each of these steps. If you can see, we'll be spending a lot of time in the EDA process, exploratory data analysis. So what this step it is all about understanding the characteristics and behavior of the data, what you have in your hand, trying to find out patterns, trying to find out meanings, trying to find out insights. So that is what this step is all about. If this step is perfectly done, then you have a good model in your hands. If this is not done properly, then you don't have a good model. So when I say that 40% of your time is going into one particular step, and you should be well versed in the tools and resources that are available for this particular step. That is the major point of having this slide in the deck. So we'll jump right in. So we are going to discuss about the tools and resources in each of the steps, right? So data sourcing. So that there are different kinds of data. So you need to be clear on what problem you're trying to solve, or are you going to jump in to just learn it? So if you're just learning, and if you want some data, can be any kind of data. It can be textual data, it can be image data, it can be video data. Almost all types of data are available as open source data sets in websites like Kaggle, um, data.gov. So in Kaggle, you can find all the varieties of data sets. So Kaggle is a community for data science. So if you're into data science, I would highly recommend you to be part of Kaggle. So Kaggle is like the Stack Overflow of data science world. So be a part of it. They also host a lot of competitions. You can even win prizes. Um, you get the data set, you get the problem statement, everything. You just need to work out the problem and then give them the best models, and then you'll get you have the chances of winning the competition. And then data.gov has data sets that are related to the government, like unemployment data, census data, agricultural produce. So those kinds of information will be there. And Yelp is a restaurant review website. So it has tons of review data. So if you're into natural language processing and comprehension, about sentimental analysis and things, so you can take the data set from Yelp, because reviews have a lot of emotion. When I review something, I put in a lot of emotion into it. It can be either anger, it can be happiness. So it's a very good data set for if you're going into natural language processing. And AWS public data sets have data sets like the MNIST, the Cipher, which are standard data sets for any machine learning in the machine learning domain. And there is Google Trends. So Google Trends is one of my favorites. So I would like to just give you a demo of what Google Trends is capable of doing. So let me just Google that, and let's go to Google Trends. So this is Google Trends, and you can search a topic here. Let's say I want to search for XAEA12, which is the name of Elon Musk's son. So when you search it, you will see a chart, a time series. So literally nobody on the earth was talking about this particular word, but then there is a spike, and this spike is the date of birth of Elon Musk's son. This is the date of birth of Elon Musk's son. So basically, you can search for anything. You can search for Corona. So there is a peak. So this is when it all started. This is when it started to be a trend. It started to become a news worldwide. You can search for anything. So this is a very good source of data. And there are other markers like the related topics, related queries. So you can even download this as a data set. You can download this time series. So if you are looking into time series analysis and trends, so Google Trends is your place to go. And there is machine learning repository, which is a collection of notebooks, data sets, public data sets, and notebook examples. So it is like the GitHub for machine learning. So this is for open data. Only if you are willing to learn, if you're looking for some data sets to learn, you come here. What if you're working on a project that collects data from sensors? So you collect your own data. So in such cases, so one common example is any IoT application. So in such cases, you might go for cloud providers like Azure or AWS. If you take AWS IoT, they provide their own gateway. So gateway is something. It's a device. It's like a modem. It's like a modem to which you will connect all your sensors and actuators and all the devices that you want to connect to the network, to the gateway. So you'll connect all your devices, And this gateway is connected directly to the cloud through high speed internet. So all your sensors will be talking only to the gateway. The gateway will keep on collecting the data. Uh, it keeps storing for a time buffer, and then it will push everything to the cloud. And then in the cloud, you can do any kind of analysis that you want. So we'll be talking a lot about AWS in the upcoming slides because AWS has a lot to offer, and we haven't explored even there's a lot to offer. So we need to go through a lot of AWS services, and there will be a lot of information about that in the upcoming slides. So in some cases, you might have collected a data set, and that data set will not have any labels. You might have collected thousands of samples of microscopic images of blood samples of COVID patients, say for example. So, but you don't have the labels to those images. And if you want somebody to come and label those images, you can outsource that work. This is a very boring work and highly monotonous work. And yeah, if you have such kind of work, what you can do is you can upload your data set to outsourcing websites like Amazon Mechanical Turk or Cloudflare, and you can pay for the services. You can pay, and people will sign up for that, and they will go through each and every images and label it for you in whatever schema that you want the image to be labeled. The people will do it for you. Actual people will do it for you. So, and then you just have to pay for the service. That's it, and it's a very little amount. And there is visualdata.io. If you are working on image processing, and image processing is your, or computer vision or machine vision is your forte, and that's your main domain, you can visit visualdata.io for some sample data. And and sorry, yeah, please go ahead. I'm not able to hear you. Is that a question? Okay, so we'll continue. So data cleaning and EDA, as I said earlier, is the most important step in any data science project. So, and to do this step, there are a lot of free resources available. So oftentimes, I hear people saying that they have a lot of interest in data science. They want to get into data science. They want to become a machine learning specialist. But what is stopping them? They give a bunch of reasons, which we'll see in the upcoming slides. But the most common reason is they don't have a powerful laptop. They don't have a powerful desktop computer. But there are tons of resources that are freely available. Say Colab, for the example. Colab is a cloud application from Google, which is absolutely free. This is pretty similar to Jupyter Notebook. So people who have already worked on Jupyter Notebook will able to like see the similarities. But Google Colab is much better because I'm now presenting this deck on a computer with just 4 GB RAM. So if I want to do some machine learning or deep learning stuff, my laptop is definitely not capable of handling the pressure. But if you go to Colab and just run the first code block, you will see that it is allocating and it's connecting. And what is it connecting to? It is connecting to a computer in the cloud. So when you run this notebook, you get an instance, a computer started up in the cloud, and then whatever you do, any execution that you do is not running on your laptop, it is running on the cloud. And look at the configuration of this computer. So this computer has 13 gigabits of RAM and 100 GB of hard disk drive. That's massive. Even my personal laptop doesn't have this kind of configuration. So all this is free for you. The only requirement is that you just need to have a Gmail account, and then you can just start working on it. Even if you're working on your personal machine, you have to go through a lot of hassle. You have to set up Python by yourself. You have to install the necessary libraries and everything. But everything comes as a package, and that too for free on Colab. So you have to make use of it. And Jupyter Lab or Jupyter Notebook is an application that you can run on your personal machine, which is pretty similar to what you have seen in Colab, pretty similar. but only thing is it runs on your machine. So if you don't have a powerful machine, go for Colab. And there is RStudio. So there is a big debate going on between the people who use R and people who use Python. I personally prefer Python. There's a lot of reasons why I prefer Python is because oftentimes people will think only about creating the model. They don't think about what are you going to do once you have the best model that you desired. Once you have the model, what are you going to do? So they don't ask this question. So until this point, until getting the model, RStudio is good. Even Python is good. But when you discuss about the deployment part, when you have the model and you want to put it on the cloud or put it inside a web application and then open it to your users, so in that aspect, Python is better than R. So these are some of the libraries for data cleaning and EDA. So we have NumPy, which handles arrays differently. So they are called NumPy arrays because they are designed with optimization in mind. So with parallelization in mind. So NumPy is like the core library. Many libraries are using NumPy, like Pandas, SciPy, Scikit-learn. So they use NumPy. And then Pandas is like the SQL of data science. You can create data frames, play with data frames, filtering. So most of the data cleaning part has to be done with the use of pandas. And matplotlib and cburn are visualization libraries. And scikit-learn, of course, has a lot of machine learning models that are commonly used in fields like science, engineering, and mathematics. And there is beautiful soup, which is a data crawler. So if you have a website and you want to get data from that, say for example, you have the cricket scores website like Yahoo Cricket or something, and you want to get the scores data ball by ball, actually you need to be paying for the API. You shouldn't be doing this. Just for educational purpose, I'm saying. Uh, you can get the data directly from the website using beautiful soup. And Keras and TensorFlow are predominantly machine learning and deep learning libraries. They have a lot of libraries related to CNNs. So if you are into deep learning, you should make use of TensorFlow. And TensorFlow is designed with parallelization in mind. So the performance is much better than other similar libraries. There is PyTorch, there is Keras, but TensorFlow is better because the way it handles the data and the code is different. It is built with parallelization in mind, optimization in mind. So you need to go with TensorFlow if you are dealing with data intensive tasks. And there is a huge support, huge community for TensorFlow. So you need to keep that in mind, which you won't get from PyTorch or Keras. And there is XGBoost. XGBoost has been the trend in the last 3 to 4 years. So if you go to kaggle.com and then go to the competitions page, and then look at the winners of the recent 5 to 10 competitions, all those winners would have used XGBoost models. So why is XGBoost having that kind of commendable uh, performance? It's because it is a gradient boost method and it is also designed with parallelization in mind. So when you start training the model, the tasks are split and assigned to multiple threads so that they all run in parallel. So that is why XGBoost is faster and gives higher accuracy. Since it is faster, it is able to train better, and since it can train better, the accuracy is also better. So let's come to the deployment part. So you have your model ready and you want to put it somewhere. So let me ask you this question. So you have the model ready and you want to put it somewhere. Would you go to a store and buy a computer by yourself? Or would you build a data center by yourself? Let's imagine that you're a company. And would you build a a data center by yourself? Or would you make use of something that is already available? Whatever you're asking for is already available and available in a better form and available in a cheaper form. and that person who's going to give you the service is saying that he will take care of every maintenance task. So would you go for this, or would you build it on your own? So this is the question that a lot of companies are facing right now. So startups are they want their product to be launched quickly, so they often go for buy rather than build. But big companies have already built a lot of resources. They are finding it difficult to move to the buy path. So why you should buy is because, as I already told you, the provider of these services are giving you maximum flexibility, scalability, maintainability, low costs, high availability, and resilience. We'll go through each and every point and discuss the importance of these points. So first thing is flexibility. Say I've just bought a computer and I'm going to host my deep learning model there, and people are going to use it over the internet. And suddenly I feel that I don't no longer need that computer because I ran out of business. I ran out of business. I don't need the computer. It's a waste of money now. So selling it is a unnecessary headache for me. So, but in case of this cloud computing, you don't have to worry about that. It's a matter of just a mouse click. You can just terminate the instance and then forget about it. That's it. The computer is gone. And then about scalability, this is something a lot of companies have not thought about when they started the company. There are two kinds of people. The first set of people think that they will not get any higher number of viewers, so they'll start with a very minimal spec computer as their server, and then suddenly their business kicks in. They get a lot of viewers, but the server is not able to handle the pressure. Server will not be able to handle the load because the server has minimal spec. Now, scaling it up is a problem for them because they need to buy a new set of computing resources and then they have to scale it up. So this is scenario one, and in the scenario two, so these people, they when they jump in, they put all their money in and buy the best computer in the world. They get high-end spec computer, but their business won't go as they planned it to be. So they are not getting as many viewers. So what happens is they have a supercomputer sitting somewhere, but no viewers. So that's a waste of money, waste of computing resources. Again, they need to sell it. So these are unnecessary headaches. So if you are opting for cloud computing, the scaling up, scaling down, or scaling out, all this can be done with just a few mouse clicks, or even can be automated using apps like Kubernetes, which are Docker orchestration and cluster management applications, which can take care of this automatically. So whenever you get more viewers, more instances will be started automatically, and the load will be evenly spread. So the viewers will have the best experience and seamless experience. And of course, there is no cost of maintenance. You just need to pay for whatever you're using. So you don't need to buy it. So there's a lot of cost saving there. And high availability. Availability is a very important aspect that you need to consider, especially if your application is a mission critical application. Let's take an example. So let me bring up my calculator. So you go to a cloud provider, say IBM, and IBM is promising that their systems are 99% of the times available. So let's do a simple math. So there are 365 days in a year and 24 hours in a day. So that gives us 8,760 hours in a year. And IBM has promised us that their systems are 99% of the times available. So I'm going to calculate what is the 99% of 8760. So we got this number. I'm going to find the difference, number of hours that we lost. So I'm going to subtract that. So as you can see, we are not able to access the system for 87 hours. So for 87 hours in a year, won't be able to use your machine. That's like almost 4 days. So almost 4 days your system will be down. So, and what was the number the cloud provider has given us? 99% of the time it is available. So 99% is still a poor value. So even 99% is a poor value, but there are cloud providers like AWS, Amazon Web Services, that offer 99 point and then 7 nines after the decimal point kind of availability. If you do the math for this, you will get the downtime in milliseconds. So which is pretty good. Even your private data center will not be able to promise this kind of availability. And resilience. So resilience is something which is related to backup and restore. So if something happens, something has to happen to your computer should be able to go back to the state when it was working fine. Say you put a file into your computer and the file was crashed, file was deleted, would you still be able to get the file? If you are not able to get the file, then you obviously don't have any resilience. But if you put the same file in a cloud provider like AWS S3, that file will be replicated and stored in multiple data centers across the world. So even if an entire data center has to go down, maybe for an earthquake or tornado or something, entire data center goes down, still you'll be able to access your file because it was duplicated. So these are the questions that I asked at the beginning of the presentation. So when someone says that they want to get into data science, but there are some things that are stopping them to get into data science, usually these are the three things that are stopping them. First thing is they don't have a powerful computer, they don't have a graphics card to do image processing, and what if my requirements changes? So the first two things, almost all the three things can have a simple single answer, which will be coming in the next slide. So the third option is, what if my requirements changes, which is analysis paralysis. So oftentimes people, before getting into something, they do a lot of analysis, too much of analysis that they won't ever start doing it. So they will do a lot of analysis and then they will just back out. So to deal with all these three problems, there is a single efficient solution called the cloud computing. And I'm going to introduce you to a wonderful ecosystem called AWS. So AWS is from Amazon. There are tons of services, more than 1,000 services. So let's not go into the 1,000 services. Let's just focus on whatever comes within the machine learning. So that is AWS SageMaker. AWS SageMaker is not just a machine learning development tool. It is a full-blown pipeline. You can make use of the notebooks that are available in SageMaker, do your training there, do your data cleaning, exploratory data analysis, like how you do in Jupyter Pi or Jupyter Lab. You can do that on AWS SageMaker. And once you are satisfied with your data, you can train it within SageMaker. When I say training, it's not like just model.train and then wait for 5 to 10 minutes for the model to train. If you're using AWS SageMaker, you can train for 30 days, 45 days. So your model will be training on the cloud on multiple machines. So actual industry grade training, not on a single machine. So multiple EC2 instances or computers will be connected together, and then SageMaker will be putting your model into these computers, and will be all these computers will be training for 30 days, 40 days. And once the training is complete, you get the model, and then SageMaker also gives you the option to deploy it and access it via the API gateway. So it's like a full-blown pipeline for machine learning and model training and deployment. So that's what AWS SageMaker is. And then there is NLP. If you're into NLP, you can make use of Comprehend. So if you go to Comprehend, um, let me quickly sign in. So this is the AWS management console. As you can see, there are tons of services. All these are services. So if you want to get a new computer, you can go to the computer section. If you want to get some storage, you can go to the storage section. But we will be focusing only on the machine learning section today. So even in the machine learning section, there are like 12 to 15 services. Let's look at Comprehend first. So the service, if it is available in the region, it will take you to there, and then just click on launch, and then you can do some real-time analysis. So this is the text, this is a sample text, and then just do analysis. You get a lot of information from that. So it says that this is a company, this is a place, this is a time, and this is a person. So that's what Comprehend does. So if you're into natural language processing, you can make use of Comprehend, and all of this is available to you. Okay, so you don't have to rebuild everything. You don't have to reinvent the wheel. You can just make use of what's available there, already available as an API. You can just make calls to this Comprehend and do your NLP. So that's AWS Comprehend, and that is Amazon Poly, which is a text to speech converter. So if you have used any audiobooks, so this is extensively being used in Amazon Kindle. So it reads the book for you, which is Amazon Poly, and the opposite is Amazon Transcribe. So if you're going to a lecture, you can just start recording the session on your Amazon Transcribe. So there is a similar version on Google as well. So it will keep listening to your presenter and it will type the notes for you. So that's Amazon Transcribe. And there is Amazon Recognition, which is an image recognition application. So if you're getting this kind of error, you just need to change to a different region. Usually all the services are available in Northern Virginia. So just let's do a demo of Amazon Recognition. So there is an image and it has clearly segmented different objects, and it's able to identify that. So it says this is a person, this is a skateboard, these are cars. What I'm going to do is I'm going to test with my own image. Let's try uploading an image. So these are default images from Windows. So let's upload the penguins and see what happens. So that's uploading. Let's see if it's able to identify penguins. Yeah. So it has accurately said, it's with 99.6% accuracy said that these are penguins, these are birds, these are animals. It even went further and tried to identify the type of penguin, king penguin. Not sure if there's a kind called king penguin, but this is impressive. So the thing is, it's not just a demo. You can actually use this into your product, whatever you're building. So you can make use of this as an API. Like how I just posted an image. So if you just open the request, so it will look like a JSON like this, and then the response comes in the form of a JSON like this. That's how powerful it is. So oftentimes we don't make use of things that are already available and try to reinvent the wheel, which you don't have to do. And there is Amazon Textract, which is like if you feed in a Word document or a PDF into the Amazon Textract, it will be able to identify the different sections in the document, and it will give you the data in a more presentable form. Let's quickly demo that as well. Again, if the region is not supported, go to Northern Virginia. So almost all the services are available there. So let's try Amazon Textract. So here's a sample document. It's a sample document, and it has extracted it into raw text, and there is forms. So basically, these are all key value pairs. There's key, there's value. So there's key value, and if you go to table, the entire table is converted into a data frame. So this is a data frame now. So that's Amazon Textract for you, and this is Amazon Lex, which is the engine of Amazon Alexa, which is a chatbot. So let's quickly go ahead and build our own chatbot in 2 minutes. So this is Amazon Lex. What I'm going to do is just going to quickly sign into my console. Yeah, so I'm going to go to services and then go to machine learning section and then go to Amazon Lex, which is the engine of Amazon Alexa. Let's click get started. So there are some sample recipes already available. You can either build a chatbot. So there's a chatbot for booking trips, booking, ordering flowers, or scheduling appointment. I'm gonna go with schedule appointment. So schedule appointment bot. So leave everything as it is. We are not going to cover that. So configuring this itself is a separate session. So if you're interested in that session, you can just go to Algomist Labs and then register your interest. So we'll get back to you. So if you want to learn how to do the Amazon Lex and stuff. So so if you yeah, so this is it. I'm just going to test the bot. So there is a so I'm going to say hi to it. Okay, I'm going to chat with it over voice. Uh,
I didn't understand you.
I
What
hope
would you like me to do?
I hope you guys can hear what it is saying. So I'm just going to say, um,
I didn't understand you. What would you like me to do?
book me an appointment.
What type of appointment would you like to schedule?
Haircut
When should I schedule your haircut?
tomorrow.
When should I schedule your haircut?
So that's it. Like so, you have Alexa in your hands, so you can just make use of this chatbot in your application. You don't have to build them from scratch. So you can just go here and keep on adding different constructs so that the chatbot gets smarter. It's already very smart. If you want, if you're intending to make it smarter, you can do it. So that's Amazon Lex, and there is a search service which is pretty much like Google for your company. If you have a company and you have a lot of documents, so Amazon Kendra is a search engine for an enterprise level institution. So if you want to check out the different products AWS is offering, you are welcome to go to this link and then check out the services for yourself. So deployment. So you have a model and how do you deploy it? So this is a very sample pipeline. So you have your training code here, whatever code you have written in Python and R, and there is your data source. So you bring them together and run them on a Docker or a series of clusters of Dockers. And once the training is completed, you put the model into Amazon S3. So now you have the model ready, which is a very good model. Now you want to open this to your target customers or open it to the world. So to do that, you need to deploy them as a service. You have to deploy them as a infrastructure. You need to make use of infrastructure as a service, which is easy to in case of AWS, which is a computer. So you host the model into the computer and then create an API. We'll see about APIs in the next two slides. So once the API is ready, you will open it to the world, and then the customers can maybe like how we have seen the Amazon recognition, where we uploaded a picture of three penguins, and then it went into the cloud, and then it was processed in Amazon's machine somewhere in the cloud, and then went through the model, and then the results we received back again. So which is pretty much the same. So that's about deployment, and we have reached the final part, which is the API. So APIs are the way of using any service. So if you take any service, everything is API. So even your model can be deployed as an API. So this is how an API works. So you have a service hosted on the cloud. It can be an image recognition software, maybe like Amazon Recognition. We just use. So it's running somewhere in a machine in the cloud, and I've created a API gateway, which is like a menu card. You walk into a restaurant, and you'll be given a menu card. on the menu, you'll be listed out with the different services that particular restaurant offers. So, and then you pick one. So it is kind of like the menu card of a restaurant. So that's what the gateway is. And then you pick a service. So these are the customers for the restaurant. They pick a service. They pick a service, and then the API gateway will route to that particular service which is running on the EC2 or any instance, and then processing everything will happen in the cloud. Only the result will come back again to the user. That's what APIs are. So there are different kinds of APIs. APIs can be written in SOAP, they can be written in REST, they can be written in CoAP. CoAP is for IoT, and REST is extensively being used right now for any website. And SOAP was used for building websites like 5 to 10 years before, and now it's predominantly REST APIs. So that's the AWS API management system. This is Amazon's. So you can host your service here, your model, your deep learning model, or anything, any prediction model here as a AWS Lambda function, or run it on an EC2 instance. There are other ways of doing it as well. And then you create a API gateway listing all the services your model or your function is offering. This is the menu card. So you have a menu card, you have the services ready, and then the users can access your services via the API gateway. That's how simple it is. So I've also listed a few learning resources. Just make use of these links. So Kaggle is pretty common. Almost like everyone would have already mm, been familiar with what Kaggle is. So anyway, go through it. And AI Hub is from Google. It has a wide ton of notebooks and data, sample notebooks and data. And then Katacoda. Katacoda is Katacoda is mainly about machine learning plus deployment. So they give you a practice environment. You can directly work on the environment, which is an instance for free, and then you can even deploy it. So it comes with Kubernetes and stuff. So you can create a Docker set of Dockers, and then set up a Kubernetes to manage the cluster. You can even do that. So all of this for free for learning purposes only from Katacoda. And Analytics Vidya is an this is also a community, data science community. They share a lot of newsletters, articles, kind of like Stack Overflow. So you can make use of that as well. So that's it from me. Uh, Thank you everyone for joining this session. And once again, I would like to give my special thanks to Dr. Palni Dhanaraj